We're now in section E, expressions with radicals. This is on page 7 of the worksheet. So for each expression below, write if the result is A, rational, or B, irrational, if it's an irrational or irrational number. So the way we want to do this section is we're going to plug in these expressions that have a radical in it and place it into the calculator and then get a result and see if that result is rational or an irrational number. Now this sign over here, if you remember from the previous section, this check mark basically means a radical sign. For this course, we talk about the radical sign for a square root. That means the square root of the radicand, that's the number inside of the square root. That means one number multiplied by itself is equal to 65. So we're going to plug this into the calculator and then press enter and see what the result is. So see question number 1. It says radical 65 dash. Again, if it's in between two numbers, the dash means minus. That's minus 3 radical 42. So you're going to plug that into the calculator. You go to second right here, second. And then we have the x squared that gives you the square root. If you see it in blue, there's a lot of things in blue. If you press second and you press the button over here, you'll see that's on top will become the square root. You then put 65 in here, 6 and then 5. You then have to click to the right. You have to get out of the square root. So you click to the right. This will bring the cursor and the calculator out of the square root. And now you're over here, and then you're going to click. This is a dash. This means minus. In between two numbers is going to be a minus sign. So you click the minus sign. It's a longer line like this. Then you have 3. See 3, and then radical is second, x squared is the radical, 42, and then you click enter, and you'll see this number, negative 11.37996. In your calculator, if you do it, it'll be much longer. I just didn't show all the numbers, but if it shows a lot of numbers after the decimal point without any pattern whatsoever, that means it's going to be irrational. So this is an irrational number. And the answer, it says for each expression below, write if the result is A, rational, or B, irrational. And the answer, therefore, is going to be irrational. So therefore, the answer is B. Right? Irrational numbers are numbers that the numbers after the decimal point go on and on and on forever in a non-repeating pattern, and they therefore cannot be written as a fraction with an integer on top and an integer on the bottom. A rational number is the opposite, and the numbers after the decimal point either stop, so like 1.5, 1.5 would be irrational, or it goes on and on and on in a repeating pattern like 0.33333333, and rational numbers could be written as a fraction. 0.33333 is 1 over 3. Also, all integers are rational numbers as well. The number 5, the number 100, those are all rational numbers. Number 2 now, we have radical 5 times. That dot means times. That dot means multiply. That's radical 5. So you do second x squared, and you get the radical sign. You then put a 5 in it, and then you have to go out of the radical sign. So you have to click this button right here. This button gets you out of the radical, the square root, gets you out of it, and then you click multiply right here. It gives you this star sign, basically. Then you have another radical, so second x squared, and then 45. You then click enter, and you get 15 is the answer. 15 is rational, right? It does not have numbers after the decimal point that go on and on and on in a non-repeating pattern. Therefore, it's rational. Therefore, the answer is A. Now, we did this a couple of sections ago in section B. The sum means you add. The sum of two numbers means you add it. The difference of two things is you subtract them. The product means you multiply, and quotient means you divide. So the difference of radical 25 and radical 9 means that in the calculator, you're going to do radical 25. So that's second x squared and then 25. The difference means you subtract. So therefore, you use the minus button. But you have to go out of the square root. So you have to press the right arrow key. This brings you out of it. Press minus. And then radical, that means second x squared 9. Right, radical 25 is one number times 20. One number times itself is 25. Therefore, it's 5. And one number times itself is 9, which is 3. Therefore, the answer will be 2. And 2 is a rational number. Therefore, the answer is A. The sum of radical 16 and radical 5, the sum means you add. So radical 16, second x squared 16. And then you add. So you have to go out of the radical, press the plus button, and then do second x squared, and then put a 5, press enter, and you'll get this long number. You see the numbers after the decimal point do not have a pattern to it, and they go on and on forever. The calculator does not show every number until infinity, but it shows like the first 9 or 10. Therefore, you know it's irrational. So 6.2366, those are irrational numbers. Number 5, 2 radical 11 times 3 radical 11. So you do 2, and then you do second second x squared, and then you get 11. And you put 11, and then it's out of the square root times 3 radical 11. You press enter. And you get 66. 66 is also, it's going to be a rational number because that's an integer. Integers are rational numbers. Here are the answers to the rest of these questions here. Number 8 is in parentheses. You'd have to do open parentheses, second x squared 3, close parentheses, multiplied by open parentheses 2, radical 9, close parentheses in the calculator. These are the other answers for the questions here. Now, an important point, and this is something that I've seen on past Regents, anything you add or subtract to an irrational number will always result in an irrational number. So if you have an irrational number, if you add to it, the result will always stay irrational. So let's say we have radical 6. Radical 6 is irrational. Why is radical 6 irrational? If you remember from the previous section, if the radicand is not a perfect squares are whole numbers who if you square root it, will have an integer as the result, meaning that a number times itself is equal to the radicand. In this case, an integer times itself is equal to the radicand. In this case, the 6, there's no integer. Integer are, again, numbers without fractional components, so it doesn't have any number after the decimal point. The number 6 is no integer that multiplies by itself equals 6. 3 times 3 is not 6, is 9. 2 times 2 is 4. So 6 is not a perfect square. Therefore, if it's not a perfect square, the radicand is not a perfect square, it's going to result in an irrational number. Therefore, whatever you add or subtract to this radical number will always result in an irrational number. So let's say we add 4, the result will be 6.449489, because radical 6 is going to be 2.449489, and so on. If you add 4 to it, you then get 6.449489. So therefore, if you add or subtract any number to an irrational number, it will always result in an irrational number, no matter what. Say radical 2. Radical 2 again is going to be an irrational number because it's not a perfect square. There's no integer that multiplies by itself into the number 2. 1 times 1 is 1, not 2. So therefore it's not therefore it's going to be not a perfect square, and therefore it's going to result in an irrational number. Therefore, whatever you add or subtract to radical 2 will always result in an irrational number, no matter what you add or subtract to that number. Radical 15 again is also not a perfect square, therefore it's for sure also an irrational number. There's no square root of 15 is no integer that multiplies by itself that equals into 15. Therefore, whatever you add or subtract to it will always result in an irrational number. However, multiplying two irrational numbers could is in highlighted because it doesn't mean will always, but it could result in a rational number. For instance, we have here radical 8 times radical 2. So if you multiply these two irrational numbers, they're both irrational because they're both non-perfect squares. Radical 8 does not have an integer that multiplies by itself to get into 8, and radical 2 does not have an integer that multiplies by itself to get into radical 2. Therefore, if you multiply them together, though, and this is a rule with square roots with, you don't really have to know it so much, but now with radicals, if you multiply two radicals together, you multiply the radicands to get the new radical, which is radical 16. So radical 8 times radical 2 will equal to radical 16. You multiply the radicands together to get radical 16. Radical 16 is a perfect square because it has an integer that multiplies by itself to equal to the radicand, which is 16. And that integer is 4, right? The square root of 16 is 4 because square root of 16 means one number multiplied by itself is equal to 16, and that's going to be 4. 4 is rational. These two by itself, radical 8 and radical 2, result in irrational numbers. However, if you multiply them together, you can get radical 16, which equals to 4, which is a rational number. So therefore, you see two irrational numbers could result in a rational number. Radical 12 times radical 3 will equal to radical 36. Radical 36 is 6, which is rational. Radical 12 and radical 3 by themselves are both irrational. However, if you multiply them together, you get a rational number. However, many times, if you multiply two irrational numbers together, you usually will get an irrational number as well. Radical 5 times radical 4 will equal to radical 20. If you put radical 20 into your calculator, also, radical 20 is not a perfect square, right? There's no integer that multiplies by itself to equal to 20, right? 5 times 5 is 25, so for radical 20 is going to be irrational. If you put it into the calculator, you'll get 4.47213595555, and it just keeps on going, no pattern forever, so therefore it's irrational. Here are some points here. Rational plus minus irrational is always rational. Rational plus minus irrational is always rational, like 5 plus 4, 2 plus 7, and 10 minus 3 is always going to be rational. Even 1.5 minus 3.6 will always equal a rational number. Irrational plus minus irrational, or irrational plus minus irrational, is always irrational. We saw that before. If you have an irrational number, it doesn't matter what you add or subtract to it, it's always going to result in an irrational number. And here we have the last point. Irrational times irrational is always going to be rational, right? 5 times 4 is 20. 13 times 2 is 26. These are rational times rational numbers, always equal rational. However, irrational times irrational will usually be irrational, but there are times that an irrational number could result in a rational number, as we saw before. And that is the end of section E.